Hello students, in previous lecture we have constructed some new matrix from old matrix. In this lecture also we will construct new matrix from old matrix. So take the example. Let XD be a matrix space. XD be a matrix space. Y is equal to set of sequence xn such that x bar is sequence in x. For x bar comma y bar belong to y, we define the matrix B star of x bar y bar is equal to summation of n is equal to 1 to infinity d of xn yn upon k plus d of xn yn into an, where k greater than 0 is positive real number and summation an is series of convergent series of positive real numbers, that is ans are greater than 0, ans and k are greater than 0, then yd star is a matrix space. So firstly, we have to show that D star is well-defined function on class of sequences. So step first, to show D star is well-defined. So for this, zero less equality of xn yn upon k plus d of xn yn less equal to 1 for all n, as k is greater than 0. So numerator is greater than denominator. So this number lies between 0 and 1, and therefore 0 less equal, if I take this to be bn less equal 1, so bn into an, this must be less equal an for all n, bn for all n, because bn lies between 0 and 1. If I multiply any number by number lying between 0 to 1, means if I multiply these ans by bn, then bn an must be less equal an, and therefore 0 less equal summation of bn an, this must be less equal summation of an, this is less than infinity. Summation an is given to be convergent series. Therefore by comparison test, for convergence of series, summation of bn into an is convergent. But what are bn's? Bn's are nothing but d of xn yn upon k plus d of xn yn, means it is precisely this, which implies is d star of 0 less equal d star of x bar y bar must be less than infinity. Implies is d star is a well-defined function. Well-defined. Now we have to verify this function d star satisfy metric axioms, means we have to prove D star is positive valued, D star of xy greater than or equal 0, D star of x bar y bar is 0 if and only if x bar is equal to y bar, means that two sequences are equal, symmetry axiom hold, and triangle inequality. Okay, so M1 by step 1, D star of x bar y bar is greater or equal 0. Summation Bn An greater than 0 means D star of x bar y bar must be greater or equal 0. M2 D star of x bar y bar is equal to 0 if and only if summation of Bn An is 0. If and only if Bn An is 0 for all n, since Bn and An both are greater than zeros, and Bn's greater or equal 0, An's are positive number. So it is sum of non-negative terms whose sum is 0. So this infinite sum is 0 if and only if each term in that series of non-negative real numbers must be 0. If and only if Bn is 0 for all n, since An's are positive. As Bn's are 0, if and only if d of xn yn upon k plus d of xn yn is 0. Denominator is strictly positive. So this term is 0 if and only if xn d of xn yn must be 0, that is xn is equal to yn for all n, if and only if x bar is equal to y bar. X bar is equal to y bar. Thus, M1 M2 axiom holds. Now, for symmetry, so in the D star of x bar y bar, D is symmetric on xd, and therefore d of xn yn is written as d of yn xn, and then we will get this sum is equal to summation d of yn xn upon k plus d of yn xn into n, which is precisely d star of yx. So this is obvious, just by property of d, obvious, as d is metric for x. Triangle inequality is important part here. Okay, triangle inequality. Okay, M4 triangle inequality. So by previous example, sigma of xy is equal to d of xy upon 1 plus d of xy or k plus d of xy is metric for x, and therefore sigma of xn yn is less equal sigma of xn zn plus sigma of zn xn for xn, yn, zn lying in x actually, for all n. And therefore, sigma of xn yn into an, this must be less equal sigma of xn zn an plus sigma of zn yn an. This implies summation of sigma times xn yn am n equal to 1 to infinity. This is less equal summation of sigma xn zn am plus summation of this sigma zn yn am. We'll get this. But what is sigma of xn yn? Summation n equal to 1 to infinity d of xn yn upon k plus d of xn yn into an is less equal summation d of xn zn upon k plus d of xn zn into an plus summation d of zn yn upon k plus d of xn zn zn yn an. And therefore d star of x bar y bar is less equal d star of x bar z bar plus d star of z bar y bar. Thus d star satisfy all axioms of metric and therefore y d star is a metric space. Y d star is metric space. So here I have used previous example as well as properties of convergent sequence, and to get the positive axiom I have considered the sequence a series of positive real numbers which is convergent. And with help of that we have constructed that. Means we know that geometric series summation of 1 upon a raised to I equal to 0 to infinity converges to 1 upon 1 minus a, where 0 is less than a less than 1. So if I take a is to be 1 upon a raised to n here and a lies between 0 to 1, then this gives rise to infinitely many matrix on class of the sequences defined on set X. Very useful example. Now on collection of sets we'll define one metric. Next example, let X be collection of finite subsets of set A. It must be non-empty first. Define D for A1, A2 belongs to X. We define D of A1, A2 is equal to number of elements in A1 symmetric difference A2. Then XD is metric space. XD is metric space. As A set A1, A2, this is your symmetric difference. As A1 and A2 are finite sets, A1 minus A2 union A2 minus A1, which is nothing but A1 symmetric difference A2, which is subset of A. A1 is finite, A2 is finite, therefore A1 minus A2, A2 minus A1 are finite, their union is finite, and that two sets are also disjoint. So this function is well defined. Okay. So first M1 D of A1 A2 is equal to number of elements in A1 symmetric difference A2 is equal to number of elements in A1 minus A2 plus number of elements in A2 minus A1, because these are disjoint sets and this is greater or equal 0. M2 D of A1 A2 is 0 if and only number of elements in A1 symmetric difference A2 is 0. If and only if A1 symmetric difference A2 must be empty set. If and only if A1 minus A2 union A2 minus A1 is equal to 5. And if and only if A1 is equal to A2 set. If A1 equal to A2, then we will get this symmetric difference to be empty set. So D of A1 A2 is 0 if and only if A1 equal to A2. Then symmetric difference operation is commutative. D of A1 A2 is equal to number of elements in A1 symmetric difference A2, which is same as number of elements in A2 symmetric difference A1. D of A1 symmetric difference A2 is equal to number of elements in A1 symmetric difference A2, which is equal to number of elements in A2 symmetric difference A2 A1, which is equal to D of A2 A1. Therefore, symmetry axiom also hold. M1, M2, M3 are verified. Triangle inequality. Okay, to show D of A1 symmetric difference A2 less equal D of A1 symmetric difference A3 plus D of A3 symmetric difference A2. Okay. So, if I have three sets A1, A2, A3, so this collection, this is nothing but part 4, shaded portion, A1 symmetric difference A2, number of elements in A1 symmetric difference A2. Now, A1, A2, A3, A1 symmetric difference A2, A3. So, it will become this one, A3 so union of shaded portions. So from Venn diagrams, number of elements in A1 symmetric difference A2 must be less equal number of elements in A1 symmetric difference A3 plus number of elements in A3 symmetric difference A2. And therefore, triangle inequality hold. Thus, these satisfy all axioms of metric, and hence, this is a metric space. Okay. So, I have explained so many examples on matrix. Go through exercises from Introduction to Matrix Spaces by P.K. Jain book. You can also use methods of real analysis by R.R. Goldberg. Then Introduction to Topological Spaces by G.F. Siemens. And go through the exercises, try to solve them. In exercises, there is one more important example is there. If XD is a matrix space, then D star of XY defined as minimum of 1 comma D of XY is metric for x. If I replace that minimum by maximum, then it is not metric. How it is not metric? Verify which property failed there and go through the exercises for your practice. If you have any difficulty in problem solving, then you can ask me by social media like WhatsApp, Gmail, or by phone also. Now in next sessions, we'll start theoretical part in metric spaces. Thank you. Good day.